Whenever we say reaction, we always have the idea that a certain amount of the reactant, when reacted under certain conditions of the temperature and pressure, the reactants will be getting completely to the product. There won't be any reactant left, right? There is nothing wrong in thinking that way. Of course, at preliminary level, it's fine, but there are many reactions when performed in a closed vessel, they doesn't go to the completion. They attain something called as equilibrium. Hi, I'm Indresh Naik, chemistry faculty at Prabhu classes. So we are going to learn about the equilibrium in this series. So what does this equilibrium mean? What exactly the word equilibrium mean? I'll just give you a raw example. Like if there is a, let's consider this way. What is a basic criteria? I will say that a basic criteria for the equilibrium to exist is a closed system. Closed system. This is the basic criteria for the any equilibrium to exist. Let's say there is a beaker over here and it is closed, and this is the acetone which is being filled into it. There is a acetone over here, and we know that acetone is something which is volatile, right? It evaporates at a room temperature. That is what the volatility is. Now what will happen after some time? There will be certain molecules of the acetone which will be getting evaporated, and it will be staying over here. This will happen, but till when it is going to happen? After some time, we are going to understand that the level of the acetone has gone down little less. It will go so low that it won't be observable also, right? It will go down, right? And we feel that okay, there are certain number of the molecules which has evaporated and it is there in the molecule. See, this acetone will be a transparent thing and it will be invisible to our eyes, but actually what happens is that we feel that okay, this much of the acetone is there and there is no more evaporation taking place inside that beaker. But let's say that what happens exactly at the equilibrium is that, let's say there are 100 molecules of the acetone which are there in this free space. Okay, they will be under constant kinetic motion, right? So 100 molecules are there. So what has happened? The evaporation has happened. There is a evaporation which has happened of the 100 molecules. So there will be another process, opposite process, a condensation, which will take place simultaneously. Means 100 molecules are gone into the vapor, right? So at the same time, after some time, the 100 molecules will be coming down and 100 molecules will be going up. Like this evaporation and the condensation process between those 100 molecules will keep on going. But for our eyes, we will feel that the reaction has come to the completion. This stage of the evaporation and the condensation both taking place at the same speed, same rate, is called as a equilibrium. This is just a raw example which I gave you about the equilibrium. Equilibrium is very vast. Okay, we are going to see the different aspects, different conditions of the equilibrium in the further lecture. So let's write the topic. Equilibrium in physical processes. Okay, equilibrium in physical processes. So first I will discuss a solid and liquid equilibrium. Now melting. Let's take a ice. It's very simple. Let's say this system is closed, and system here, since we are considering ice, we have to consider the isolated system. because here temperature will be very much involved in this equilibrium. Let's take one ice cube, it is this way, and let's put it into water. I am putting it into water, and there is no exchange of the heat from the system to the surrounding and surrounding to the system. Let's understand that this is isolated system. So what is going to happen is that if there is no exchange of the heat from the system to the surrounding or the surrounding to the system, this ice is not going to melt, right? If you keep this into a water, for our eyes, it is like ice is there intact, it is not melting. But what actually happens is that a melting is also happening, right? Here there is let's say this is a surface of the ice, and actually what happens in this case is that some of the ice molecules will be going into this water. At the same time, with the same rate, some of the water molecules are getting solidified on the walls of the ice. This is a solid liquid equilibrium. Now there is next equilibrium is a liquid vapor. Liquid vapor equilibrium is the one which I explained you at the beginning of the lecture. That is what the liquid vapor equilibrium. This is, then there is a solid and the vapor. Okay, then there is third category I will write, that is solid and the vapor equilibrium. Third, solid and the vapor equilibrium. Now solid getting converted to the vapor. Okay, solid getting converted to the vapor. Like very best example we can take is the iodine. Iodine is the one in which solid will be getting converted to the vapor. 1 minute, students, I'll just check the frame. Okay, frame is fine. So what I was discussing was iodine, right? Solid and the vapor. Solid getting directly converted to the vapor. Iodine. Let's take this iodine, and it is in a closed system. Here is the iodine solid. What will iodine solid? It will be getting converted to the vapor, right? Then that vapor and the solid will be in equilibrium, means the solid will be getting converted to the vapor with certain rate after some time, and at that equilibrium point some of the vapor getting solidified with the same rate. We call that to be a solid vapor equilibrium. Now let us go ahead with the equilibrium in physical processes where we include a dissolution. Okay, solid where we include a dissolution. Dissolution means solid and the liquid equilibrium. Solid and the liquid equilibrium means, take a liquid, like let's take an example of the sugar, right? We are trying to dissolve a sugar in a water. Like we find that certain amount of the sugar can be dissolved in a certain amount of the water. I am not talking the point where you take very high quantity of the sugar and very less quantity of the water and you make it very thick. That is not the condition I am talking of. I am talking of this condition. You take a glass of water, and pour some sugar into it, right? Pour some sugar into it. What will happen is that after some time you are dissolving, maximum portion of the sugar will get dissolved, no doubt, right? There is maximum portion of the sugar which is going to get dissolved into the liquid. But after some time you will find that there are some particles of the sugar which are not getting dissolved at that temperature, however hard you may try it, right? You are dissolving, trying, stirring and stirring, but it is not going to dissolve. There are certain particle, a fraction of the particle which will be remaining, and that is not going to get dissolved. At that time, we have to add more amount of the water. Now I have to add more amount of the water and now try to stir it, and it will start dissolving. But what exactly happens at this stage when the particles are not getting dissolved? right? At this stage, there is a dissolution process and the crystallization process, right? Like for this, let's say there are how many, let's say for our simplicity, let us say there are 100 particles of the sugar, small particles of the sugar is not getting dissolve, however hard you may try. At that level, what is happening is that a recrystallization of the sugar particle which are there already, there will be 100 recrystallization of the 100 new sugar particles, and these 100 which you are able to see, they are getting dissolved. This happens at the microscopic level. Okay, for our eyes we feel that these 100, like these are the 100 which are not getting dissolved, but that is not the case. At this stage there are certain other 100 getting recrystallized, and at the same time these 100 are getting dissolved. This is the stage where we say that water cannot accept more of the solute, the saturated solution. This solution is called as saturated solution. The meaning of the saturated solution is that a solvent cannot accept more solute. Solvent cannot accept more solute, right? If we want to dissolve more amount of the solute, we need to add more amount of the water. So this is a solution, what we call it to be a saturated solution. This is about the solid and the liquid equilibrium. Next is dissolution of gas in liquid. Next is dissolution of gas in liquid. How we can dissolve a gas in a liquid? For example, a carbon dioxide, right, is there in a soda bottles. There is a carbon dioxide dissolved in a liquid. So how much amount of the carbon dioxide or how much amount of the gas can be dissolved in a certain amount of the liquid? We can say that according to the Henry's law, what it says is that Henry's law, the mass of a gas which is getting dissolved in a particular amount of the liquid or a given mass of the liquid is directly proportional to its pressure of the gas. More is the pressure of the gas, more will be the amount of the gas which will be getting dissolved in a liquid. So M is equal to KHP. KH is a Henry's constant, right? So here mass of the gas getting directly proportional, mass of the gas getting dissolved should be directly proportional to the pressure of the gas, and this is the equation for the Henry's constant. But there are certain conditions for the gas getting dissolved in a liquid, that a gas should be inert. It shouldn't be reacting chemically, and it should not give you a product. This is the first condition for this condition, right? We say that gas to get dissolved in a liquid as per this law. The second law is like gas ammonia gas cannot be reacted, or ammonia gas cannot be dissolved in water because it is going to react with water to form ammonium hydroxide. Such type of gases cannot be dissolved in a solvent or liquid or water which reacts with the solvent. Another thing is HCl gas. Okay, if HCl gas is there, that is also not possible to dissolve. HCl gas is also not possible to dissolve in a liquid because HCl is going to dissociate. HCl is going to, if HCl is there, this is going to, when it is reacted, when it is in water, it is going to get dissociate as H plus and a Cl minus. As it is very strong acid, it gives its ion. So these are the conditions. These are the limitations of the dissolution of the gas in liquid. Further, let us understand general characteristics of the equilibrium. How the equilibrium should be. First condition, so general conditions, I will say, the general conditions is, first should be, it is a system should be closed. System should be closed. Only in a closed system the equilibrium will take place. The next condition is the equilibrium is always dynamic. Equilibrium is always dynamic. Dynamic means, let's say there are like, let's take an example of the physical equilibria only. That sugar, some amount of sugar is not getting dissociated, right? Not getting, let's say this 100 particle, small particle of sugar, for our eyes it is not getting dissociated. But what is happening? At the same time, there is a dissolution of the sugar into the water. At the same time, there is a recrystallization of the sugar, right? These both the processes take place at the same rate, forward reaction as well as the backward, dissolution and the recrystallization. Or in the case of a vapor and the liquid phase, it is a condensation. Vapor and the liquid, it is a condensation and the evaporation, which takes place simultaneously, right? So both the processes taking place for the certain concentration only of the reactant and product. The forward reaction and the backward reaction taking place at the same speed is called as a dynamic equilibrium. All the measurable conditions. Third is all the measurable quantities. All the measurable quantities are constant. Means if we want to measure, let's say, a concentration at the equilibrium, let's take that same example of the physical equilibria, where the sugar what you took at the beginning of the reaction was, let's say, 2 gram, right? 2 gram of sugar you took and you started dissolving. Like, the reaction is happening means what? The sugar 2 gram which was there, it is getting dissolved into a water, right? From 2 gram, out of 2 gram, just 0.1 gram is now remaining, and there is certain concentration of the liquid. There is a certain concentration of the liquid that has gained due to dissolution of the 1.9 gram of sugar. That 0.9 gram, although there is an equilibrium, the dissolution and the recrystallization or the precipitation, that is what we say, is taking place simultaneously. Although this process is taking place there, the concentration of the undissolved sugar, that is 0.1 gram, is going to remain same. That is the third general. Like I did write a conditions. The condition is the only one. This is, the system should be a closed system. These are characteristics. We can say that these are characteristics of the equilibrium. Equilibrium is always dynamic, and all the measurable quantities at equilibrium are constant. Let's say this concentration, this 0.1 gram is not getting dissolved. So although both the processes taking place simultaneously for this 0.1 gram of sugar, that will remain as a 0.1 gram only.